pulled together and then coming back to putting steps to what we did for the example. Okay. We're going to find the value of c given this function. F of x is going to look like a piecewise. F of x is 3x minus 2 if x is less than or equal to negative 3, and it's 4c minus x if x is greater than or equal to negative 3. And the rest of the directions here would be to make f of x continuous. Okay? So we want to find a value for c, and I have one c here, so I'm trying to figure out what that number has to be in order to graph this function and have it not have a break. Because this looks like a piecewise, which means probably if we graphed it, or probably normally, it would have a break somewhere and then it would not be continuous. But we're trying to find a value that will make these two parts connect so that it is continuous and it won't have a break. I guarantee that you will have at least one question like this on the AP exam. It's on every AP practice test that we've ever done. Sometimes there's even 2 of these. And these are not difficult to do. Okay, these are not hard to do, but we practice them a lot because these are 2 easy points to get, because they're not hard. And the directions are pretty much always the same. Find a value of this variable to make this function continuous, and it will look like a piecewise. In order to do this, we have to evaluate limits from the left and the right, because way back in these steps of continuity, the limit has to exist as x approaches c. Well, in order for a limit to exist at a particular value, the limits from the left and the right have to be the same. Like whenever we've talked about limits, both the left and the right, both of them have to be going towards the same y value in order for there to be a limit at that function. If they're 2 different, totally different values, like if it's oscillating or you have an asymptote, then you don't have a limit. So we're going to use that fact here and evaluate limits from the left and the right. So we're going to look at the limit as x approaches 3 from the left first. And that little negative sign indicates coming from the left. Now, we have 2 scenarios here. You have 3x minus 2, you have 4c minus x. Which part of those, or which function, 3x minus 2 or 4c minus x, which one is to the left of this cutoff value of negative 3? Negative 3 is where stuff is happening here. And that's why, oops, sorry, this should be a negative 3, not a positive 3. And I should have said that's why I chose negative 3 as my limit value that I'm approaching, because that's where the break is going to happen if it happens. Okay, so what function is to the left of negative 3? How do I know which one it is? Because it's less than. Good. So if you look at this domain, this tells me something about this function. It tells me that this function only exists for x values that are less than negative 3. Okay, so 3x minus 2 is my function on the left. Now, coming at it from the left, can I directly substitute? We can evaluate this like we evaluate every other limit. Does direct substitution work? Yep. So I'm going to plug that negative 3 in for x. And what do you get when you do that? Negative 11. Okay. So I have negative 11. That's my limit value from the left. Then I evaluate it from the right. Okay. Now what function is to the right of x being negative 3? 4c minus x. Okay, so is to the left of negative 3. This is to the right of negative 3. Can I directly substitute? And I have two variables there. Where does that negative 3 go? No, it does not go for both. Just for the x. Good. They will eventually. Yes. Okay, so we're going to plug negative 3 in for x here. And I get an expression. I don't just get a number. I get 4c plus 3, right? Okay. Now, 4c plus 3 and negative 11, these both represent the limit as you get closer to that negative 3 spot on the graph. Now, in order to be continuous, the limit from the left and the limit from the right have to be equal. So we're going to actually set these two limits equal to each other and then solve for c. So you take negative 11, set it equal to 4c plus 3. Because remember, our goal was to find the value of c that makes this graph unbroken, makes it continuous. Is it easy to solve for c here? Sure. We subtract 3 from both sides to get negative 14, and then divide by 4, and you get c equals negative 7/2. And I think that's it. Now what this means is if I plugged in negative 7/2 here, I would get, what, negative 14? Yeah, negative 14. And then if I graphed negative 14 minus x and 3x minus 2, they would actually connect then. They wouldn't be broken apart. They would actually meet at that point of negative 3, and then your graph wouldn't be unbroken. Yes?
Do you have any like variable spaces for that too?
Not for these. What would happen, this is going to be on a multiple choice part, most likely. So you'd have to do the work, and then this would be one of the options that you could pick. And it might be in fraction form, but they might have put it in decimal form too. So just depends on the problem. Okay, so steps to making a function continuous. Again, the setup for all these problems is going to look very, very similar to what this looks like. Find a value of a variable, given this piecewise function, make it continuous. What's the first thing that we did here after we wrote out the problem? We evaluated the what from the left and the right? The limit. Okay. So steps to making a function continuous, you have to evaluate the limits from the left and right. Use the domain value as your x approaching c. Domain value being, this is my domain for both of those functions, telling you something about them. So the c value that you would use for the limits, you're going to get from that part of the function. And then after we evaluated it, what did we do with both expressions? Yep. So set the limit expressions equal to solve for the variable. Okay. And we'll do another one here too. Good. Okay, here we go. Find the value of c given f of x is equal to x squared minus 4 if x is less than or equal to 4, and 2x squared plus c if x is greater than or equal to 4. Okay. On your own, before we start going over it, I want you to try to set up your left and right hand limit expression. So like what we did up here, in these two spots, I want you to try to do for this function. I should add make function. Okay. Go with Michaela, what's the c value that you used? 4. Good. And then let's start with the right hand side. What function's on the right hand side?
Are you still asking me?
Sure.
Oh, okay. Well, I think it would be 2x squared plus c.
Good. Should be 2x squared plus c because that's to the right of my c value. Okay, we'll evaluate it in a minute. And the limit as x approaches 4 from the left would be the other one, right? X squared minus 4. Okay, directly substituting 4 in here gets me what expression? To this one. Because I can directly substitute in for x. 32 plus c, good. And then here, directly substituting gets me 12. Okay. And then what was my next step after I evaluate from the left and the right? Set them equal to each other. So we take 32 plus c, set it equal to 12. It looks like c has to be negative. Negative 20. And we're done. Okay. These are not too bad. And there are some problems for you to practice on your L4 practice, but we'll see more of these as we go on because I don't want you to forget how to do these because I know guaranteed you're going to have at least one or two of them. And these are pretty easy points to